Okay, as I was saying earlier, the actual slide deck has been stolen by first mover advantage on me in some of these. So I'm not going to. I mean, the way to actually describe this is probably for some of the people in the audience, they would have seen this before, and the idea was that we just again wanted to highlight, what you can get out of the data by just looking at it. So we're looking at this purely from a parametric data perspective. So the data that you see here and the analysis that we're doing initially was based on parametric data, which is the data coming directly from your fridge systems, primarily based around temperature, because obviously that's what refrigeration is all about. The second half of the conversation, or the second half of the presentation, is going to be done looking at the electrical usage data. And the electrical usage data is obviously meter data coming from your fridge systems, and that's actually turning out to be very, very insightful in terms of being able to just use electrical usage data to interpret how your fridge systems are performing. So I guess in the absence of a parametric data, electrical data in its own right can actually tell you quite a lot of what's going on in your environment. So I guess ideally having both, and we'll show examples here of where both electrical and meter data comes together, parametric data and electrical data comes together, is actually, kind of the ideal scenario, because now you can actually prove out what you're doing in terms of any changes that you're making or any interventions that you're making. But beyond that, there's other data sources, and I think we heard the discussion this morning around IoT, and also the generation of data from different disparate sources. We talked about weather data this morning as one that we'll talk, in the actual presentation, but there's other sources of data that are coming in that are useful. I think there was, kind of anything to do that's relevant to your system. If it's readily available, you can actually import that in. So you're not limited to proprietary data sets. You can actually avail of a lot of the other data sets that exist in the ecosystem. Now, apologies, but this connection is not clicking in. So anyway, while we're getting that going, I'll just give you a bit of history and background. Again, John has kind of alluded to some of this, but just to give you some background. So we started working on this project about 3 years ago, and our actual involvement was purely to look at a problem that Tesco had at the time, which was that they had a very good infrastructure. There was a lot of good data being generated from the fridge systems. It was all centralized into one centralized system, both electrically and from a parametric perspective. But it wasn't actually, I guess, being properly harvested. So John felt that there was an opportunity to say, look, we've done all this upfront work, we've invested all this money in terms of infrastructure, and we just need to try and get more out of the data. So 3 years ago, we got started at looking at, rather than looking at the overall project, we tried to come up with a feasibility study that showed that, look, what can we do as a kind of a use case or a point solution, or kind of a valued sort of feasibility study that gave something worthwhile back to Tesco with looking at the data. A lot of it has been talked about around, a lot of it's been talked around defrost, right? And we started just looking at defrost purely because it was a piece of data that was readily available to us as a kind of a clean data set. There are flag sets, as you know, within defrost systems, and Danfoss is no different than any of the other controller types, but there's a defrost flag set within the system that allows you to actually extract that data from a timestamping point of view. Sorry, just wrong. So, let's go back to start. So what we started with was looking at defrost, and it turned out actually that defrost is not a bad starting point, purely because not only is it a kind of easily kind of assessed in terms of its performance, it also turns out to be quite an impressive energy saving opportunity. One of the things that we could do with the data as we collected it was, as we combined the electrical data with the parametric data, it was possible actually to quantify the cost of defrost in terms of the number of cycles that you're performing in your estate. So what that meant was that we were able to establish how much energy was involved in generating, or what was the cost of doing an actual defrost. Now, in defrost terms, there's two elements to it. There's the resistive heating load within the defrost cycle itself, which is the heat that you're putting into the cabinet to achieve the defrost capability or the de-icing capability of on the evaporator. But the other element of it is that if you're pumping heat into the actual process, you have to take it back out again. And I guess when you combine the resistive load and the increase in cooling demand that comes about from that scenario, when you combine those together, you end up with a very, very significant saving. So while defrost was our starting point, it also turned out to be a really good, useful use case to say, well, look, if you're trying to figure out where the value of data analytics is coming from, defrost is a very, very good starting point. And what I wanted to do was to share a couple of slides that you haven't seen already with the audience. I'm not going to dwell on these. These are all the kind of the why did we choose refrigeration? I'm sorry, just to go back one of the first things we did was when we assessed where IBM could get involved here with Tesco, it wasn't necessarily refrigeration as our starting point. Our starting point was the usage data of energy within Tesco. It just so happened when we actually drilled down and looked and talked to the client on this, it turned out the refrigeration was, as John had highlighted in his slide, this was the main source of energy use within, well, practically 30-40%, and in fact some of the stores we've seen that's actually even higher. That's what we thought was the biggest bang for the buck when we got involved in this originally. One of the other key items that, and we'll talk about it, and that's why I wanted to open up the forum later on to the Q&A thing. It's all well and good developing assets or insights as to what's going on in your data. The big trick is figuring out how you actually turn that into something that's actionable and the intervention that you can do. I've been involved in this kind of energy analytics, as I say, and energy management for about over 10 years now. And I remember being really excited one day of actually coming up with all these rules, and we did some original work in building management systems, and we started doing all these rule-based analytics back 6 and 7 years ago, and we came up with all these fantastic insights about air handling units that were, simultaneously heating and cooling, and they were out working out a schedule, and everybody, I thought this was a major breakthrough, and went back to the community with my, eureka moment, and the guys kind of looked at it and said, yeah, that's fantastic. Now, leave me alone and go back to my day job. Not then realizing that just because something's a good thing to do doesn't necessarily mean you go do it. And that was my kind of light bulb moment, that really you're only as good as the people that are going to implement the changes. And that's probably one of the key findings of the work we've been doing with Tesco over the years, and is probably a credit to the teams that are involved in this, the maintenance teams and the Tesco management and engineering teams. It requires a lot of hard work and effort to keep on message and to keep focus on the intervention plans. And again, going back to defrost, it's a simple enough, in theory, idea that you will try and standardize your defrost policies across the estate. The reality of that is it's quite difficult, and I'm sure the people in the room that are here will all have their testimony as to why that doesn't work, in theory. Now, having said that, and what we will be able to show, and I think John showed it in the actual slides, we are making progress, you can see, and the other great thing is we can actually feed back to the teams directly the actual progress they're making, because you can see both in terms of tooling that you have to show compliance rates, or in fact in the electrical usage, which is really where the bottom line is, you can actually see that value actually coming home and show that you're actually making the implementation changes that are actually driving savings on the ground. Okay, so again, this is just a landscape thing. We're probably jaded from seeing slides about how much data is out there, and we're all dizzy from it. At the end of the day, in the case of Tesco in Ireland, it's 8,000 fridge estates. Looking towards the UK, you multiply, it's 150 stores. It's 2,500 stores in the UK. So the maths on that just pop it up, out of the park in terms of what amount of data you're dealing with. So in the context of where we're going, like our key focus, and I guess what we were trying to do originally was, as I said, generate an impactful KPI to show the value of analytics, and that's why we focused on defrost. The other key concept of what we were trying to describe also, however, is we didn't want to start overlapping or playing in the space that exists today and managed successfully by companies like IMS Evolve, who are here today, and Zito, who are also here, and others that do a very good job at monitoring performances of fridges. So this is a requirement, both health and safety, and obviously for equipment, proper equipment performances, it's essential. We wanted to move beyond it and look at an analytics layer that basically
wasn't looking at the real-time data. We weren't not so much interested in it, we just felt it wasn't of any value for us to be involved in real-time data reporting. So we're working on the premise that what we're bringing to the table is some form of screening analytic. So screening analytic to us means, yes, taking real-time data if you wanted to apply, but it wasn't just solely looking at electrical usage data, it was parametric data, it was whatever data that you needed to assess. It was the concept of being able to apply your analytic across the complete estate. The idea here was that you were kind of screening for particular types of behavior that allowed you to focus in on what mattered in terms of what was interesting to the follow-on root cause analysis. So screening analytics is basically where we live, and that's our first element of what we try to develop out in this analytics layer. The other key elements of findings from the work we did with Tesco, as I said, we weren't interested in real-time data. Aggregation data and some of these graphs, which I'll show and which John showed earlier, all relate to data that's been aggregated at a monthly level. Now, you think at some point that's not going to be of any value, but what we have found continually is that actually gives you 85% of what's going on in your estate, looking at aggregated monthly data. And you can see the consistency month in, month out of how a case is performing or a pack is performing. You can actually see how consistent it is when it's performing well and how much it starts to drift over time when things don't work out the way you want. So one of the first things we did with the data is we said, look, we're looking at aggregation here. We're not going to go in looking at whatever 11 million data points. We're just going to aggregate it down and come up with a number. And that was part of IBM's sort of core skill set, which is taking large data sets and doing some front-end pre-processing of data that brings it into any potential engine. That includes, by the way, that denoising element that I talked about earlier. We need to get the data in, but we need to make sure that the data is of sufficient and proper quality that when we do start to apply our analytics, that we're not going to be back to the question of, oh, do we understand it or do we trust the data? So that's a core element of what we do in research within this space, not just for refrigeration, by the way, but for any data sources that we touch. We have to look at some sort of aggregation of data and cleaning of data, and that's what we did in this case as well. Now, for the purposes of our data involvement with Tesco, we actually ended up scraping data from the IMS portal, and basically that is just both IMS and the ICT energy data. So we basically took the data and imported it into our, I guess, took the raw data and generated these aggregation data sets that we could then start to use and analyze along the way. I mentioned about the raw data denoising. The metadata integration is the point I think that Wasim made earlier about the data is only as good as the contextualization of it in terms of it's just raw data. Unless you can link it to some sort of hierarchy or ontology, then it's not going to be of no real value to you. And this, I guess, is me kind of speaking beyond just the refrigeration space here, because we've lived in building management systems, or I have, looking at this data sets for 10 years now. And time again, the bit that keeps coming back is the one that's the most challenging of all, is linking the metadata. So that's the referencing of the actual data, kind of the ontologies, the labeling, the type of data that you're looking at, how the cases are labeled, how they fit in within the ontology in stores and within the estate, and the disparity in terms of how that data is actually, the metadata that's the sources of those metadata, how disparate they are and how disjointed they are. At some point right now, the industry, not just in refrigeration, but generally within the data acquisition space, is looking almost as a manual process of generating the contextualization of the data. So you're pulling in all the manual data sets, the drawings, the label maps, the whatever, the BMS data point, label names, and you're trying to bring them all together so you line them up with the actual data that you're looking at. And that's probably the most challenging of all in terms of this whole, and again, we're speaking from our side of the house, and be interested to see what others said along that way. But literally, it's trying to make the data, make sense of the data and contextualize the data. And we've done some work on this, and we've done some patents, again, because we knew that this was an industry problem. And we're trying to get that into some form of automated way. So we're using some of this stuff, the cognitive computing ideas to try and reason out when we look at a data point. Can we assess, can we make a good attempt at understanding what this data is without the need for some manual intervention? And that's something, another kind of pain point along the way that can't be overstated. Without the contextualization of the data, we're just looking at just random data, and we know there's something in the pattern, but we don't know what it means to the end user. And then, as I say, we've integrated the electrical energy usage along the way. The other quick slide I wanted to talk, and that's really back around what we were talking about, the engagement model and the intervention implementation gap. This was a complete team effort in terms of getting to that end point. We all contributed to that success story of looking at these significant energy savings, as John put up in the slides. But it required constant feedback loops. So we met weekly. The experts would come back and say, look, we think this is what the data is telling us, or this is what the signature of a particular behavior is within a case or a pack. And we would take that away. And my job was almost like a translator as an engineer to the core expertise within the analytics space, within research, was to translate the problem from the real world to the world of mathematicians and statisticians and data miners and just basically the people that had the knowledge to be able to extract out the actual, the real value. And then to take whatever came back and to filter it, because some of the stuff comes back is of no value to the end user, and actually just come back to a point where you go back to the client with, this is what we think is useful from the analysis we've done this week on the data set that we focus on. And that iterative process happened, and by the way, it's ongoing. It's been going on now for probably close to 3 years. And it is that kind of technique. It's not an isolated unit where data sent to us in isolation and we come back with some kind of rough ideas as to what's going on. This had to be closed loop, and that's why that slide is probably the most important slide that I can put up here today if I'm asking, or if I'm actually letting people know, like, what is the experiences of getting involved with kind of data analytics. You need to be right in the middle of it for it to actually operate and to operate effectively. Okay, I'm not going to dwell. So obviously, sorry, one other thing to say about our data and presentations here. We're kind of under NDA to talk about the latest data that we're doing in our latest work we're doing with Tesco. The stuff we're showing you here is 18 months old, okay, because of where we're at. So this stuff, and I know the kind of journey continues and companies are beginning to recognize that this is the area that there is value in. We've already moved on a generation, and we're actually now looking at the pack energy side, looking at some really interesting models that we're developing around the use of electrical energy use data with parametric data to come up with some models of how pack, which is the demand side or the supply side of your refrigeration equation, where the real energy is used in terms of compressor loads and condenser efficiencies. That's the area that is really, really exciting for everybody, because the prize is so big in terms of energy saving. But this is just a kind of a cycle of where we've actually positioned our original analytics set in the demand space, which is on the defrost phase. You've got 3 phases: defrost phase, a recovery phase, and your steady state phase. So this was your famous slide that we've done and kind of flogged around for quite some time. It basically brings one other angle, as I said to you, that I won't dwell on it. So this is basically the time where in fact, I think Kieran is in the audience here, it was pioneered from the work that was done in Wilton and down in Cork. I'm not saying it's from Cork or anything, that we were the foresight was there. But Kieran was involved in this original project to basically get to this. So this is a store in Cork, and basically when this actual step happened, it was work that the guys had engaged in, and the maintenance teams were saying, look, we want to do something around defrost. Let's look at the estate. This data was starting to come out to say, look, we're doing crazy amount of defrosts on our estate. Can we do something to show value and move us on? And in fact, and we probably can get to the actual date of when you actually did this, but you can actually see it happened literally overnight. The reason I know that is because we can see it on the data set from the electrical data. Now, this is the resistive load I'm only talking about in the freezer cases. So literally, you can see the step change. You can look at your electrical data, and that's what you got. The 14th of November, I think it was 2013 or 2014. It was going back a bit anyway. But that's the thing we were looking for from a data analysis point of view, because once we were able to do that, we were able to extrapolate out what actually happened both at the This is at the case level, by the way, so this is the case, the resistive load within the cases, and this is what was happening at the pack level. So we were looking at the pack as well and seeing where the data is actually flowing. So those two pieces of information and working backwards on, and it wasn't hugely scientific, it was literally, we could literally tell the number of defrost cycles that had happened within that period, and we were able to go backwards and establish, I wouldn't say categorically, but with very, very strong sort of confidence that we were actually saving 200 kilowatt hours per day in that store for having made that policy change. The upshot of it is there's a little bit more, so now we have moved this on, so we are be able to kind of come up with demand profiles. I'll touch on that for a finish in a second, but we are able to kind of quantify what this actually means at the cooling demand, or sorry, the cooling supply side as well. The upshot of it is that you're looking at somewhere the order of about 100 megawatt hour saving per year per store by reducing the defrost cycles to 1. Now, I don't know, again, we have a couple of energy procurement people in the room, so I'll be conservative here and say at roughly 10 cents a kilowatt hour, that equates to about 10 grand a year per store by doing just that one change. So, as I said, we started like just looking at refrigeration, defrost as an example. It turns out to be probably the first one that you could go back to a client with and say, look, if you can manage your defrost cycles and get them to a kind of a base level that is agreed as a policy within the actual engineering teams, you're talking about saving 10 grand a year per store. Now, when you multiply that up to 100 stores, that's the type of flavour. Now, that's the single KPI looking at type of saving value that you're talking about. There are other examples in here. I'm not going to dwell on them. These are slides that we kind of, as I say, put together on talking about maintenance-related stuff. And John alluded to it earlier about we scratched our heads to figure out why we were half the duration, defrost duration on some stores than others, because it was quite clear that there was such a disparity. Some of that turns out to be case type and things like that. Other things related to how we were doing defrosts and whether we're defrosting on time or on temperature, also the position of the probes. There was a load of deep dive stuff that went into understanding why there was a difference between. But the driver or the trigger for all of that was this disparity originally. We talked about the defrost, but I just want to kind of just say something very quickly on this. This is probably the most neatest one of all in terms of taking the direct parametric data and predicting something that was happening at a case level. The ice-up scenario that we were describing here, so this is the termination temperature for your cases that we were aggregating on a monthly basis. This is all monthly aggregations, or in this case, they're daily aggregations. You can see here that the termination temperature aggregations were 0. And, when we actually looked at it, it meant that the actual probe, the S5 probe, had to be frozen. It wasn't actually in clear air. So it was never going to reach its termination temperature. So working backwards on that, it was possible to start looking at defrost termination temperatures and its drift over time to, 1, declare whether something was iced up or not, or 2, you can start to see a drift. So if you start seeing this temperature drop over time, you know that it's actually beginning to defrost or to ice up. So it was that kind of idea that you can actually use this data point, just one single data point, to start telling you that you've got something like a potential ice up happening in your environment. That's the type of thing that we were trying to bring back to the actual the engineering teams and the maintenance and management teams to say, look, we can tell you what's going on, and that's just looking purely at one data point within the space. And there are multiple and countless examples of this. I'll just stop on this one. This is the one again that was put up by John, but this was the evaporator valve duty cycles. So we were actually looking at the duty cycles. Now, when you look at these maps and stuff, we were talking about looking at whatever it is, the data points that we're generating per year, but we're looking at a yearly basis on this. So these are not just 1,000 data points, they're probably about 200, 300,000 data points. And we were looking at the overall aggregation of that data. And again, looking at the way the valve operation is distributed between one case and the next, you can show that there is repeated behavior going on there. What we were interested in, however, was this, which was to actually come up with a way of being able to automate the visual interpretation of this. Because everything we do was with the hat of looking to see, can we automate this? Because we're back to the screening analytic thing again. We can actually go out and start applying this across the estate to identify automatically what we can see visually was going on at particular case levels. So we developed this metric, and Paulito, who will be speaking in a second, will actually help to develop this out, but this is a skew metric. So we were able to declare skew metrics that were able to establish, for example, that we saw this performance. We could see visually that the actual case was performing, had moved. In fact, the valve was open all the time, and we were able to detect that as a skew metric. And that's what we now declare as our KPI for drift of evaporator valve. It also allows you to detect when it's happening, because that's the thermostatic runtime. We could actually tell when that case actually went from normal behavior to abnormal behavior down to the actual point when it actually went, because you can see the runtimes here. Thermostatic runtimes went from whatever 400 seconds up to, or 400 minutes up to 1400 minutes. So that's so again, we're looking at this purely as an energy, or sorry, as a maintenance or a data view, and that was what we were feeding back to the project teams on an ongoing basis. Final thing, we're also doing some work on the demand analytics. This is kind of the holy grail, I guess, of, and John will allude to this, it's trying to figure out how do you know how much your cases are looking for in terms of demand. We've done some early work on this, and it's moved on quite a bit since then, but what we were able to do was come up with a prediction of what minute by minute or hour by hour, whatever the terminal or whatever the timestamp is here, to detect what the demand is across each pack. So it's what cases within the pack are actually looking for that energy, cooling energy, and that's what's driving obviously your ultimate demand, to the point where we can actually determine which cases are actually performing to a demand or applying excessive demand. So if you consider this is the percentage of total demand from the case, and these are the makeups of the case, you can see here that the demand is actually the two drivers, main drivers of demand, turn out to be, surprise, surprise, the freezer rooms, and one, I wouldn't say rogue, there's a wall and well, which is the half kind of glass door and kind of well freezer within this pack. So we were able to, and are beginning to build this out now to again establish some sort of screening analytic that says, of your cases that are in that pack, these are the drivers that are causing the excessive demand or whatever the profile is demand for that pack. And it also allows you to run this continually to see when it's drifting over time, and then again you're alerting that there's something going down. On a not so much real-time basis, but on a monthly basis, you're saying month on month there's been a change. So that's okay. A whistle-stop tour of what we've done. So I want to kind of shift it now to hand it over to Bei Chen. And Bei, sorry, I'm going to do one other thing. I'm going to go for a live demo here, so bear with me here without a tightrope. So part of the work that we're trying to do along the way here is we're trying to establish an actual. So everything I've described here, obviously from an IBM's perspective, is designing a set of KPIs or rule-based systems that allows us to go after the actual data in automated roles. So it's alluding back to my commentary around the screening analytics. So what we've developed out is a supply-side screening analytics set, which is a lot of what you've seen today has been just kind of automated in a tool. We've also done some work on the deep dive analytics stuff, and Jörn Plonings, who's a colleague of mine, will talk a little bit further about that on the final session. But effectively, this is the electrical modelling of our electric usage forecasting it's simulated obviously for a particular store within the Tesco estate. But effectively, what we have is a series of stores which we just put in for demo purposes. We're basically allowing us to go in to the actual particular store and establish a series of metrics. So this is just a kind of top level view of various KPIs. In this case, it's back to our number of daily defrosts again. You can actually establish whatever KPI you want to use there. You can actually look across the estate and you can establish what the performance is on a particular month. And we're taking kind of data that's quite well, when I say old, it's not it's over a year, calendar year 2000 and January 2014 to December 2014. So basically, it's allowing you to look at specific angles and get the summation of particular data points along the way. Now, just to the point of just one thing I want to point out here. This data quality metric, as I said to you earlier, is key to our anything that we produce here within our data analytics. This is the quality metric that Ray referred to earlier. This is the data point that tells us that we've got confidence in the data that we're seeing. So we've got month on month, we've got actual compliance levels. This is not real data, by the way, so don't. So if we look at it from an actual real data perspective, what we're actually looking at here is in December 2012, these are all of the packs of a particular case type, which is full glass door, and these are your actual statuses of each of those. Now, these are just, bear in mind that these are, this is a kind of a research tool. It's used to engage with people to say, look, this is the type of thing that you need to be looking at, and we obviously want to be able to get to a point where we can kind of drill down into the actual data and understand. So this is just a very simple graph of the number of defrosts reported on that case over the months. And some of those dips, as I say, were data quality issues. If you remember back to the data points, they're data quality glitches. But what you can see here is that you actually can establish that kind of screening analytic idea, and if need be, you can go down and you can drill down to the actual case itself on the floor to see what's going down. So again, it's more of a conceptual thing in terms of what we're doing, but the idea is that we've got something that allows you to take what we've got done in the kind of the refrigeration analytics space and put it into something that allows somebody to deploy and hopefully use to monitor their estate. Okay, now hopefully just put you through on to Bay then, who'll just talk very to the next level of what we talk about in terms of analytics, and that's using electrical usage data. And Bay has been actively involved in this project now for about a year and a half, and she's looking at the electrical usage data from the actual estate.